Hi everyone, we are students from AS1204_6 and today we would like to present our topic on the determination of acetyl salicylic acid in aspirin tablets using the back titration method. Before we start, let us introduce the members of our group. Nur Batrisha, Adlina, Nur Amna Wardina, Nur Khalida and Fatin Nisrina.
So to begin with, why did we choose aspirin as our sample? Aspirin is one of the most widely used medicine around the world. It is commonly taken for pain relief, fever and inflammation. But more importantly, to ensure its effectiveness and safety, it is crucial to determine how much acetyl salicylic acid or ASA is present in each tablet. That's where back titration comes in. Now a little background on aspirin. Each tablet usually contains between 68 to 72% SA by weight. Interestingly, SA is originally derived from the bark of the low tree, which has been used for centuries, back to ancient Egyptian and Greek civilization to relieve pain. The modern form of aspirin was first produced in Germany in 1897 by biochemists. As for the technique we use, back titration, it is useful when direct titration isn't suitable, such as when the sample is only slightly soluble or reacts slowly. This process involves adding an excess amount of standard reagent to the aspirin sample, then titrate the leftover reagent with another standard solution. This allows us to accurately determine the ASA content.
Now, let's discuss about the theory behind this topic. Back titration is particularly useful for determining the concentration of a substance in a sample that is difficult to determine directly, either because of polysoluble, response slowly, or yield a product that interferes with a direct titration. Back titration, also known as reverse titration. An analyte with an unknown concentration is reacted with an excess of a known standard reagent in a back titration to determine the concentration. The standard reagent reacts with the analyte in a fixed ratio based on a known chemical equation. But why use back titration? Is it because aspirin or acetyl salicylic acid is a weak acid that reacts slowly with bases and is only slightly soluble in water, making a direct titration difficult? The use of back titration ensures that the entire sample reacts before titration, improving accuracy and making the endpoint easier to detect. Back titration overcomes this limitation by adding an excess of a strong base such as sodium hydroxide to ensure a complete reaction with the aspirin. After the reaction, the remaining NaOH is titrated with a standard acid solution such as hydrochloric acid to determine how much base was consumed. This allows for an indirect but accurate measurement of the aspirin content. In addition, aspirin undergoes hydrolysis during the reaction with sodium hydroxide, forming salicylic acid and acetic acid.
Standardization of sodium hydroxide. A standard solution of oxalic acid was prepared and titrated against the NaO solution using phenolphthalein as an indicator. The endpoint was determined by the appearance of a persistent pink color. The concentration of NaO was then calculated using the titration data and the formula, which is M1V1 equal to M2V2, where M1 and V1 are the molarity and volume of NaO, and M2V2 are those of oxalic acid. Sample preparation. An aspirin tablet was accurately weighed and crushed into fine powder. The powder was dissolved in an excess of standardized NaO solution to ensure complete hydrolysis of acetyl salicylic acid (ASA). The mixture was gently heated to accelerate the hydrolysis fraction, forming salicylic acid and acetic acid. After heating, the solution was allowed to cool to room temperature. Back titration. The excess NaO remaining in the solution was titrated with standardized HCl using phenolphthalein as an indicator. The endpoint was marked by the change of the color from pink to colorless. The volume of HCl required to neutralize the remaining NaO was recorded. Next is calculation. The amount of NaO that reacted with ASA was determined by subtracting the moles of NaO neutralized by HCl from the total moles of NaO initially added. Using the stoichiometry ratio between now and ASA, the moles and mass of ASA present in the tablet were calculated. Finally, the percentage purity of ASA in the tablet was determined by comparing the experimental mass to the labeled mass.
So now we move on to the example of result. And then we have sample of one aspirin tablet that is weight 0.325 gram acetylsalicylic acid, and then we have sodium hydroxide and hydrochloric acid as a reagent. The molarity of sodium hydroxide is 0.1 molar, while the hydrochloric acid molarity is 0.1 molar also. And then we use phenolphthalein as the indicator. Now we move on to the calculation part. So we have given information. The first one is mass of aspirin, which is 0.325 gram, while the molarity of sodium hydroxide is 0.1 molar, and then the volume of it is 25 milliliter. While molarity of acid hydrochloric is 0.1 molar, and the volume of it is 10 milliliter. And then we need to do the balanced chemical equation of this both. And then we got the reactant, which is C9H8O4, which is the aspirin acetylsalicylic acid that reacted with now, which is sodium hydroxide, and we obtain C9H7O4Na and water. And then we got the excess, which is sodium hydroxide reacted with acid hydrochloric, and then we got NaCl with water. After that, we need to calculate the initial mole of sodium hydroxide, which is multiplying the molarity and also the volume. And then we got 0.0025 mole of initial mole of sodium hydroxide. And then we need to calculate the mole of acid hydrochloric by doing the same thing, and then we got 0.001 mole of acid hydrochloric. And then we need to compare with the equation 2 to get the 1 mole of sodium hydroxide that equals to 1 mole of acid hydrochloric. By that, we could calculate the mole of sodium hydroxide excess by multiplying the equation we got earlier to 0.001 mole of acid hydrochloric, and then we got 0.001 mole of sodium hydroxide excess. And then we could calculate the mole of sodium hydroxide reacted, which we need to initial of the sodium hydroxide, we need to minus with the excess of sodium hydroxide, and then we got 0.0015 mole of sodium hydroxide. By that, we could calculate the mole of aspirin or acetylsalicylic acid reacted with sodium hydroxide. In this calculation, we need to compare with the equation 1, and then we got 0.0015 gram of aspirin reacted. After that, we could calculate the mass of aspirin reacted by multiplying the mole earlier we got and then with the molar mass. And then we got 0.27 gram. After that, we could calculate the percentage weight over weight purity of aspirin by using the formula mass of reacted aspirin in gram divided by mass of aspirin in gram multiplied by 100%, and then we got 83.08% weight over weight. And then this is the titration data that we put in a table form after calculation part. And then this is the titration data that we put in a table form after calculation part. And then this is the titration data that and this is the results of back titration and HPLC data that obtained from many countries such as Iran, UK, and also Europe, London, and a lot more. So summary, the amount of acetylsalicylic acid found is 0.27 gram, while on the label content is 0.325 gram. The difference between this mass is because difference due to possible loss during filtration, incomplete reaction, or the presence of inactive ingredients in the tablet.
Next, we can conclude that the back titration method effectively determine the amount of acetylsalicylic acid in an aspirin tablet by using an excess of standardized sodium hydroxide and titrating the remaining base with hydrochloric acid. The calculated mass of acetylsalicylic acid was 270 mg, slightly lower than the label, which is 325 mg. Overall, this experiment demonstrated the effectiveness of back titration in analyzing substances that are difficult to assess directly.